Okay, hello and welcome, class. You can see here that we are in Chapter 7 on the notes, page 40 if you like, and we're going to pick up here. This is our first video. It's going to be a test video since we've really done these two problems before, but I encourage you to watch it for a refresher because we'll be getting into new stuff very shortly, in fact in the next video. Okay. So let's remind ourselves how to do this. So we're going to draw here. Well, first let's remind ourselves of the problem. We want to rotate the graph of y equals square root x between x equals 0 and x equals 1 about the x-axis and find the volume of that solid we obtained. So let's first draw a picture. So we're going to get something like this. So let's say here's 1 and 1. We're going to get this graph, and we want to rotate it here. So switching colors, let's say to red. This is, and then we'll rotate it to get the cross-sectional area. And first thing we need to find is what's known as the cross-sectional area. And so let's pick any x value in 0 to 1. We need to know that length, okay? So let's see, a of x, and we've already done this, so let's just remind ourselves this should be pi times the radius of this disk we see here squared. Well, that has radius, it looks like the height of the function, so we'll use colors to denote that. Right, and this is just pi times x when we simplify. Okay. And so that tells us now that the volume is equal to the integral from the x bounds of the region, which is 0 to 1, a of x dx. And so that's just, let's see here, integral 0 to 1, pi x dx, which, if we integrate it, is pi times x squared over 2. And now we evaluate from 0 to 1, which is, let's see, pi over 2, well, I guess times 1 squared, minus parentheses pi over 2 times 0 squared. And of course, this is just 0, so our final answer is pi over 2. And that should already be present in your notes, but just make sure that that's what you're getting. Okay? Now we'll come down here to the next problem on page 40. Let's draw the picture. So we got the graph of 1 minus x squared, and we want to rotate the region that it forms with the x-axis. So in fact, if this is height 1 here, and this is x value 1, this is x value minus 1, what we're going to, oh, I missed. We're going to get something like this. Okay, just kind of bear with me on the picture here. And then when we rotate it about the x-axis, we'll get something like that with a cross-sectional disk, I think we see. Right. Okay, so for any x value now in this region, or in this x range minus 1 to 1, we need to find the radius of this disk. Right? So our cross-sectional area A of x is going to be pi times r squared, and we look here and our radius looks to be exactly the height of the function, which we know is 1 minus x squared. And now we simplify this, and this is pi times, and just doing some quick math in our heads here, I think we're going to get that. Okay. All right. Well, now to find the volume of this solid that pretend that you see it here. That's minus 1 to 1, a of x dx, which I'm just going to save some imaginary ink here and instead just write what I know a of x to be. Okay, and now we got to integrate this. So this is pi, and it looks like the antiderivative of x is, or 1 is x. Antiderivative of x squared will be x cubed over 3, but this 2 here comes along for the ride. And then we get x to the 5th over 5. All right, well, what that means is we plug in 1. Oh, sorry, I'm just realizing something. That should be a minus 1. So the bounds of our region are from x equals minus 1 to 1. Okay, so first we're going to plug in 1, so we get a 1 cubed here, and then a 1 to the 5th, technically, minus parentheses. You notice this pi is still out front of this parenthesis here, and plug in negative 1, so minus 2 over 3 minus 1 cubed plus minus 1 to the 5th over 5. Okay, let's simplify within each parentheses here. So we get pi 1 minus 2/3 is, well, let's just leave it like this. Let's not get ahead of ourselves. And same thing here, we get minus 1 plus 2/3. Minus 1 cubed is minus 1, so it's going to cancel with that negative. And similarly, minus 1 to the 5th is minus 1. Okay, so this is pi, and now we get a 1 minus negative 1 is 2, minus 2/3 minus another 2/3 is minus 4/3. Oh. And let's see, 1/5 minus negative 1/5 is plus 2/5. Okay, and so if we find a common denominator, we get pi with a denominator of 15. 2 is 30 over 15. We need to multiply this one by 5, so we get minus 20 over 15. And this one becomes plus 6 over 15. And you do the math here, and you get 16 pi over 15, which, if I recall from class, is exactly what we got in our notes. Okay, that's our first video. Next, we'll be doing page 41, where we learn how to use what's known as disk washer method. That's what this is called. Disk washer method, but for a rotating about a vertical axis now. So we'll be rotating about the y-axis in the next video.